help you solve a problem really, really fast. I could have done this really slowly by doing two perpendicular bisectors and solving simultaneously. That actually wouldn't have taken that long because that perpendicular bisector is horizontal and that perpendicular bisector is vertical. So it wouldn't have taken that long at all actually, but here I got this lightning fast just by remembering this fact about how a right angled triangle in a circle always goes through the centre. Okay, question 16. Okay, here's another situation where 4 points are on a circle. The summary of this chapter has 4 circle theorems, but try and remember that you learnt lots at the GCSE. What we're being given here is a cyclic quadrilateral. Any quadrilateral has has all 4 angles adding up to 360. If it's a cyclic quadrilateral, then you know for sure that the angles in the opposite corners add up to 180. That's very useful because then you only need to think about 2 angles instead of 4. That's all by the by while I draw this diagram. Negative 5, 5 is there. In fact, I know how I'm going to find the equation of the circle. I'm going to do 2 perpendicular bisectors. So I'm going to accelerate the drawing of this diagram. I'm going to do it very roughly. The reason why a diagram is still valuable is to make sure you use perpendicular bisectors that aren't the same. There's a chance if that's one and that's the other, the perpendicular bisector of that and the perpendicular bisect will actually be identical, and therefore there'll be no point solving them simultaneously because they'll have infinitely many solutions. Quick little diagram helps convince yourself that you're picking 2 that will actually intersect once. So I'm going to use those. Now, B was 1, 5, C was 3, 3. I'm going to see just how fast I can get the perpendicular bisector of this. Okay, so here's the template. I need a point it goes through. The perpendicular bisector is going to go through the midpoint of that. The midpoint is add up the x's, divide by 2. Add up the y's, divide by 2. The gradient of this join is second y minus first y, that's 2, over second x minus first x, that's negative 2. So 2 over negative 2 is negative 1, which means the gradient of the perpendicular bisector will be 1, which looks sensible because that's going up from left to right. So there's 1 perpendicular bisector. Now, what I've done here is a massive argument for this template rather than y equals mx plus c. Getting the equation of a line is done so fast with y minus y1 equals mx minus x1 because all you need to do is fill out 3 details. Y equals mx plus c only has 2 details, the m and the c, but finding c is usually much harder and requires solving an equation. I didn't need to solve an equation here, I've just laid it straight down. Now it's not tidy, that would not get full marks if you actually wanted the equation of the line, but we do not want the equation of the line in its own right. We only want to use it so that we can solve it simultaneously with another perpendicular bisector. Therefore it does not need to be tidy, it does not need to obey the normal rules for how an equation should look. I'm going to see if I can do this perpendicular lightning fast. A was negative 5, 5. Okay, so here's the template. Y minus y1 equals mx minus x1. Let's see if I can do this fast. Okay, so I need a point it goes through. The perpendicular bisector will go through the midpoint. To get the x coordinate of the midpoint, add up the x coordinates and divide by 2. to get the y coordinate of the midpoint. Add up the y coordinates and divide by 2. The gradient of this line, my diagram is sloppy because this is actually a horizontal line. Therefore, the perpendicular bisector of it will be infinitely steep. And therefore, this is a rare example where you do not use this template at all. You get the answer directly. If it's a vertical line, if this is horizontal, see how it's 5 high here and 5 high here? Therefore, that must be horizontal. Therefore, a perpendicular bisector to it must be vertical. Vertical lines always have equations. X equals something. X equals what? Just halfway between. So x equals, add them up, divide by 2, x equals -2. So I'm going to solve y minus 4 equals 1x minus 2 and x equals -2 simultaneously. I should add that this probably, in retrospect, it looks like it would have been a good idea to draw this diagram more accurately, because then I would have immediately realized that that this was a very good perpendicular bisector to take, because its equation will be so simple because it's vertical. If I had my time over again, I probably would have been a bit more on the lookout for any special numbers. You should always try and notice when, oh, how embarrassing. You should always try and notice when numbers are special. Look at this, that's the same as that, which means that perpendicular bisector is vertical. That's the same as that, which means, sorry, that chord is vertical. That's the same as that, therefore that chord is horizontal. Therefore the perpendicular bisector of that will be vertical, x equals -2. The perpendicular bisector of that will be horizontal, and I just need to know how high it is, add up the y coordinates, divide by 2. Oh, how embarrassing. Okay, so I don't need to solve simultaneous equations. That is the center of the circle. Now, don't rejoice just yet. Just because you've done the hard work doesn't mean you rejoice. You've got to make sure you've actually answered the question. What is the question? We want the equation of the circle. So it's x minus -2 plus y minus 0 equals r squared. What's the radius? The radius, now that we know that the center is -2, 0, the radius can come from the distance from this to any one of those 4 points. Let's just use a distance formula. I'm going to use this. I'm going to see how fast I can get it in my head using my snappy saying. The distance from here to here is the difference between the x coordinates just tidying this up. Okay, so the difference between the x coordinates squared plus, that was that me squaring the difference between the x coordinates, plus the difference between the y coordinates squared. So my final equation is this. It's square root of 34, you've got to square it because that's a template for the equation of a circle, so that's why it's come out as plain old 34. Question 17. The line AB is a chord of circle centre 2, -1. So that's the centre. A is 3, 7. B is -5, 3. And that's the centre. This is A, B. I'm always very attracted when I've been told something is a chord, is just to remind myself that if I went straight to the chord with a right angle, I'd bisect those. It's a very useful theorem. AC is a diameter. So that's the same as that, and that's C. Find the area of ABC. Okay, well, if that's a diameter, that's got to be a right angle. So I've been a bit sloppy here, I haven't drawn the information on. 2, -1, 3, 7, -5, 3. So what's the best way to work out the area of this triangle? We've got two formulas, half ABC sine C, much underused, and also half base times height. You got lots of choices. If you use this one, about which you regard as the angle, you could regard that as the C, that as the C, or that as the C. You also got 3 choices for when you use this one, about what you regard as the base. You can regard that as the base, you can regard that as the base, and you can regard that as the base. Now, why don't we just trying to think what's the best one to use. Since that's a right angle, why not regard that as the base? So the base is this distance. So the difference of the x coordinates squared plus the difference between the y coordinates squared. So the base, regarding it this way round, is the square root of 80. Now I need to know what that height is. I think I might be about to change my mind. So the distance from A to B is root 80. See, I know this distance. It's twice the distance from there to there. Distance from there to there, so dA to O, is difference of the x coordinates squared, difference of the y coordinates squared, all square rooted after adding, so that's the square root of 65. Okay, so therefore this distance here can just be done with Pythagoras, even though I don't actually know that point. Oh, sorry, that's AO, so the distance AC is twice that. So here's my big Pythagoras statement: y squared plus square root of 80 squared equals 2 root 65 all squared. So therefore y squared plus 80 equals 4 times 65. So y squared plus 80 equals 260. Y squared therefore equals 180. Y equals therefore the square root of 180. Normally there'd be 2 solutions to that, but because we're talking about a distance, I've just got the one solution, the positive solution. Okay, so now I'm good to work out the area of the triangle. Okay, so the area of the triangle is half the base, which for me now is root 180. The only reason for that is so I didn't have to turn the page as much, times the square root of 80. Now this definitely should be simplified. This is the area, half prime factorizing, or at least factorizing is always a good idea. So we've got a square root of 9, a square root of 100, and a square root of 8. So that's half times 3 times 10, which is 15 root 8. And why not simplify this? I mean, this would get you full marks. Just doing a bit of surds revision for you. That's 15, that's a 2, so that's why that's a 30. So that's the area of the triangle.